Concord. Okay, section 10.4. We didn't grade it yesterday because remember it was assembly schedule. Everything was shorter. You guys were like double shorter. Anyway, no, I guess you were normal. It was 2 days ago you were double short. Number 6 is C. Number 8 is D. Number 10. Final equation, x squared over 16 minus y squared over 20. I guess you could have written, because b is a nasty number once you square root it. But remember, guys, if we want b squared, do we have to do that and then square it, or can we just steal the b squared? Yeah, we just steal b squared. Makes life a little bit easier, huh?
Amen.
We like that. As long as it's, how should I say this? Done the right way. Number 26. From the equation, you should have your center at -3, 2. You should have your vertices. Wait a minute. How'd you guys get your vertices on this one? We didn't graph a lot of hyperbolas on our own. Hyperbola. How'd you get your vertices? You have your center from your HK, right? You got that. So how do we get the vertices? Not even distance formula. Check out who's down below, right? So we have 12. 12 squared is 144. We have 5. 5 squared is 25. Which one did we use? 12 because it's the biggest? No. Why did we use 12?
Because the horizontal axis.
He came first. If the x term is positive, then it's going to be horizontally oriented with a horizontal transverse axis. So we go horizontally. Whatever coefficient goes with the x term. So since the x term came first, we stole his square root of the denominator, or 12, and we went 12 to the right and 12 to the left. Vertices, check. 9, 2, and -15, 2. Add 12, subtract 12. How do we find the foci? Well, you know A and B, we use our Spiffy formula to find C. And we, once again, horizontally oriented because the x comes first. We add 13 and we subtract 13 from the x. Now the asymptotes on this one, guys, they don't just have you write the slope of the asymptotes. The slope of the asymptotes would have been plus or minus 5 over 12. Because remember, rise over run, we use the y value over the x value, so 5 over 12, b over a in this case. How do they make lines, though? Isn't this an equation of a line? How do they do that using a slope? And a point. Yeah! What was the point they used? The center. So you can use the center as your point. You can use the slope using b over a, or the y coefficient over the x coefficient. And they went ahead and just said y, which would have been y minus 2, but they added 2 on the other side, plus or minus n times x minus a, which would have been, x minus h, which would have been x plus a. Good? Sort of, kind of. We have a couple more. I think there were lots of evens at the end, just because I was trying to see if you guys could truly solve these. You can use the odds to try to kind of help yourself out, look at a similar problem, and then go back. If the foci are plus or minus 10, number 1, that's going to be horizontally oriented, because one's this way and one's that way. C equals 10. We were able to pull that out of, I think you were given that. The crazy part on this problem, I remember this one from the past. The crazy part of this problem, even though the slope is 3 over 4, so you would think underneath the y should be 3 squared or 9, and underneath the underneath the x term should be 4 squared or 16. It doesn't end up being 9 and 16. Here's the reason why. If we were to just steal the 3 and the 4, we know that a squared plus b squared has to equal c squared. Does that work? 9 plus 16 is 25. 25 equals 100. No. So what do we have to think about? Well, if it's not 3/4, what else could it have been? Isn't 6/8 also 3/4? Different variation. What's true about 36 and 64? And that's why we were able to, or you could have then been able to, if you had noticed, 3 over 4 doesn't work because that doesn't combine, a squared plus b squared doesn't combine to be n squared. But if you realize that was just a reduced form of possibly what the slope started as, and that now that that is an equal statement, then we can say, okay, 64 and then 36. Meaning the denominator, remember, for slope rise over run. Numerator goes with y's, so that's why it's under the y term. Denominator goes with x's, hence why it's under the x term. Technically done, remember. Okay, do that a different way. Their way works too. My way is just kind of like an experimental, try different versions of 3/4 that weren't reduced yet and see which one works. Both ways work. 54? Is it circle? Someone give me a quick reason why.
Equals 1.
Both are squared and both of them, not even 1, both of them have the same coefficient. So what if it was 2x squared plus 2y squared? Circle. 3x squared plus 3y squared? Circle. Unless it's a degenerate, so it's a hidden something else, like we saw in the example 2 days ago? When did we see that degenerate? I think it was 2 days ago. Who knows who I was actually talking about. Anyway, so, just kidding. Just kidding. 56. Parabola. Why? This one's easy. Oh, come on. Why is it a parabola? This one's easy.
It's only one term is squared.
Only one is squared. What are we talking about?
I don't know anymore.
Me either. Only one term is squared. So it has to be a parabola. That's the only function where only one term is squared, unless it's a degenerate. This one, hyperbola. Okay, pourquoi?
The negative.
For what negative value? Does it look like an x squared and a y squared and they're being added, so it should be like an ellipse because the coefficients are different? So this one is x squared and y squared. They're both squared, different. So
When you complete the square, what do you do?
now, there is a little trick in the book as far as multiplying the a and c as squared terms, and then you can go ahead and know for sure, without simplifying. What's going on, Jennifer? You're using it right now. Too bad I didn't have an Irish accent. That'd be even more fun to say. Okay, so if we were to simplify, we would go ahead and we would pull out the 4. We would have the y squared minus y, and then we'd have some sort of, I don't know. And then we would go ahead and take the x squared term, pull out the 2, we'd have an x squared minus 4x. And on the other side, you would move the 15, and then we would say, okay, what's going on? True? Move the 15, what's going on? Subtract the, I think I factored everything out all right. Okay, when we go ahead and complete the square, that would be negative 1. Cut in half would be negative 1/2. Squared would be 1/4. Should be 1, because of the outside. Over here, we would cut in half. Negative 4 cut in half is negative 2. Negative 2 squared is 4. 4 and 2 is 8. Dilemma. I still see an ellipse. Some of you hold the key, and maybe I just haven't heard it yet. What's the key? Why has no one told me about the typo in number 62?
When they have the AC on the bottom, it says equals to negative 2/4, but in the top it says 62 equals 4y squared plus 2.
You guys have the actual question. Turn it off. Question. Which one's right? Do you guys have the question written down? What did they give you? Was it 4y squared plus 2x squared or 4y squared minus 2x squared? Out of an entire class. Writing the directions in the problems. Come on, someone answer me. Right here, 62. Is it a plus or a minus?
Here down the row.
In the in your homework? Is it a Thank you. Right? Doesn't that make a huge difference? Here I am explaining a problem, thinking it's going to be a degenerate, because if it was a negative number and then we divide by a negative. It was a typo. I'm done. All right, let's go back to notes. You guys are killing me.
Killing me later.
Killing me, Smalls. Sorry, I was quoting a movie, so if you literally thought killing, I don't know, maybe
I get you.
blood pressure, gray hairs. Anyway, so. You guys never seen Sandlot? That's so sad.
Yes.
Oh,
Now I remember where that quote's from. Now that you bring up Sandlot, I've
So killing me, Dolly. My turn.
That's not the right response. Alright, kids, we're back in section 12.3. Now, quick heads up, we do have a test on Tuesday.
Oh, yeah.
Why?
Oh, it's fun.
Because we're finishing the last section today, like we always do. If we finish a section, we'll do the next day. We review, and then the next day. Okay. And then Wednesday, if I have any sophomores, you'll be gone for the pre-ACT, SAT, thingamabob. And then on Thursday, what's going on that day? Something special.
That's correct.
Corrections are due, right? And it's the last day for fourth period.
Get ready, you guys. Something fixing up. This morning, you junior.
You guys have a chem
Are you guys either ready? Ready?
Yeah, we
Set.
Maybe my mom should
Oh, trust me, this one's happening.
Okay, let's go.
Wait, can we go to the win sheet again? How do, if we were to grab that, how do we like?
Well, remember we have, oh, I'm just moving these slides. Okay. Remember we have our parabolas. It's kind of annoying to do a one sheet when there's super narrow parabolas, or hyperbolas, sorry. Can I make it wider just for sake of illustration? Is that okay?
Yes.
We'll zoom in and say I'm distorting the window. That's a horrible problem. Okay. If I'm revolving, if I'm spinning, right? Imagine like yesterday, and I would show it to you when Mr. Horn's trying to fix it. Because he's awesome like that.
Wait, what did you say?
If I'm, I know.
John, what did you say?
If I'm trying to spin, I mean, you're on tape, besides that. If I'm trying to spin, imagine these 2 points are fixed, like the little parabola was on the axis yesterday, and then I spin it, right? So wait, I'm not spinning this way. Which way am I spinning? This way. True? If I'm spinning this way, what's going on to my hyperbolas?
Like a donut. Like a donut.
Like a donut? I don't know, I was thinking like a yo-yo.
Yeah, more like a yo-yo.
Wait, what? Like a yo-yo?
Bruh. Come on, y'all. I'm just trying.
Right? Do you guys see it?
Yeah.
Like the inside of a yo-yo. Do you guys see it?
Oh
Like-
yeah, now I see it.
Right? It's like
Yeah.
the spinning, not the
It's like
circle
the-
ones, but the...
The
How
inside.
about a tire rim, my guys? Is that better, a tire rim?
Okay. I guess.
Maybe
like a weird.
How about an hourglass? You guys can all relate in some way, shape, or form.
Maybe it's like
Hourglass.
What if it's an air?
A tire rim. A yo-yo. Long story short,
Or apple, an apple.
an apple core that's been eaten with a little like burp-a-doop-a-doop, but without the jagged edges. Okay. Long story short, what's the difference between the 2 sheet and the 1 sheet? Come on, kiddos, focus. We can do this.
Two separate.
2 separate pieces and 1 altogether piece. Once again, if you guys want to make it try to make it cool. As you can probably do way better than me. You could do like a different, you could do like a different. You can make like a cross section you do and have fun with it. You can make it spin, spin, spin. Yada, yada, yada. Okay. What do we do when you face homework? Because homework is not just, hey, there's a pretty picture and spin it. That might be what the test is like on Tuesday. Wait, what? What?
Oh, you said there's.
I said Tuesday.
No,
Wednesday is the lunch. You said Thursday.
Let's sign up for this.
We have a chem test in Seoul.
On Tuesday?
Yes.
Yeah, Mrs. Lee and I are on point. Okay, so.
Well done.
slowly, isn't it? Okay.
Killing me softly.
You guys are writing down the example of multitasking, right?
Always.
We working hard.
Yeah, there we go.
Alright. Before we can ever rotate, before we can ever generate a quadratic surface, we have to have a beginning graph. So, we have to review everything that we've learned in 10.1 to 10.4, besides slopes and tangent lines of parabolas and inclinations and angle between. Those are the three things we won't be reviewing. Everything else we'll be reviewing. How do we graph y equals 9 minus x squared?
Okay, so we know it's going to be down because it's negative x squared, and then you go up minus plus 9.
Oh, so we don't even need all this snazzy 4p craziness with the directrix and the focus, right? Maybe we're not reviewing everything. We could just say, okay, it's going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. Really made it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we could just say it's a downwards parabola, shifted up 9. But how do we make this accurate? Where should it go?
Down.
True, but how much down?
Well, we know it's going to be like a 1, 1, and then a 1, 4, a 2, 4.
Making it easier. What am I finding right now?
Oh,
I'm finding the zeros and finding the x-intercepts. Isn't that easier? Just make life a little better. There we go. Now, question. Hold on. Why am I only graphing, if I can make it nice and pretty, why am I only graphing this part of the parabola?
Because you follow instructions.
And following the instructions. The instruction said first quadrant, that lies in the first quadrant. So I'm only graphing that part of it. Why not go down? Well, that would be the fourth quadrant, wouldn't it?
Yeah.
Why not go over? Well, wouldn't that be the second? And this would be the third. So forget that, first quadrant. Remember what I said yesterday? Somehow they're going to have to cut it, restrict it. Now, where am I spinning or revolving this about? Look for that word about. Okay, so go find the y-axis. And how do you show me, it's worth points on the test, how do you show me you're revolving it around the right place? Not just your picture. How do you start?
oh, the
Little spinny arrow, right? Show me what you're revolving about. No, kind of this one. Anyway, you're spinning. How do you guys show me the spin in the picture? Any advice for your classmates?
like this, like a elliptical thing on the bottom, connecting the two, and
So kind of like this, right? Except we do it here.
it would be the same if we spun this way.
Yeah, whether you spin like up and back, or whether you spin back and up, those generate the same. Why am I doing dotted lines? Anybody help me out? It's in the back, not the front. Good. And we can finish. Ultimately, we're going to finish the other side because as it spins, it's going to go connect on the other side, right?
Yeah.
If we want to make it fun, we can make it fun. If we don't want to make it fun, we just say whatever is good enough. I'm just spinning like whatever. Bye, Boyd. Done. Not done. Questions? Sweet. Well, that's the beginning of homework. Let's keep going. Where else might homework go?
Hyperbola.
Yes.
Hey, that's kind of nice because the word itself is telling us what we're supposed to make.
Hooray!
But how should the equation also tell us what to make?
We can
2 squared.
2 squares and a.
negative.
Now, hold on. We
From
wouldn't be used to seeing it quite like this. We would probably write the positive one first, right? Oops, not plus. That's a little x. Minus. Now we have the x minus 0 squared. Aren't we used to having a's and b's? Yeah.
Well, we can divide by 9.
Okay. Right? Isn't the standard form equal to 1, and that's how we get our a's and our b's? So divide both sides by 9, and then we have all the pieces we need to graph. Now some of you in 10.4 homework, graphing a hyperbola was where it got a little dicey, a little sticky.
A little bit.
Alright, how do we start graphing a hyperbola? Not a hyperbola, that's how we spin it. A hyperbola. Center. Okay. Now what? Is this an up down or a right left?
It's a
Right. Positive. Who comes first?
it's hard. No,
If it's a Y, you fly. Where's that hyperbola? No, you fly. Right? The Y axis. It's going to be an up down one. It's going to have a vertical axis, transverse axis. So, think of it this way, you're going to be adding to the y's. Adding what to the y's? Oh, adding 3 to the y's to get to the vertex, right? And for a hyperbola, how many vertices do we have? 2. 1 up, 1 down. In this type of example. 1 up, 1 down. How do we know exactly how wide this hyperbola is supposed to go?
The restrictions.
True. They told us x equals -6 to 6, so we could kind of cheat a little bit, I suppose. Typically, at this point, we would go ahead and find the slopes of the asymptotes, and we would say, hey, it's the y coefficient, the a, over the x coefficient, the b. And this one are the same, so I guess it wouldn't be that tricky. And we would go up 3, and then we go over 1, 2, 3, over 3. Technically, probably should do like a dotted line to get there, though. Some of you might remember, it depends on how you were taught last year. You might have made like a, because it's going plus or minus, you might have made like a rectangle to help you with yourself out. Then you have your asymptotes. Going up 3 over 3 and going down 3, right 3. So you could have done all that. Some people maybe learn to write the box. Going right 3, left 3, up 3, down 3, forming the box, and then connecting. That's how some people learn to make hyperbolas. It's actually drawing the box. You could just use the slope from the center. And then you could sketch. Now I did see a question. Go ahead. What's the question?
Is M just equal to A over B?
Yes, except remember that the y's and x's can switch position. So the safer way I would say to think about it is instead of over B and A and remembering which one's B, which one's A, just think rise over run. So take the one that's under the y over the one that's under the x. Does that make sense? It's a little bit safer. But yeah, you could say that. However, did you guys hear me a second ago talk about the cheater wing? I was showing you that because that's how you need to be precise with hyperbolas, right? That's how you need to be precise with hyperbolas because that's what we were talking about in section 10.4. I was a little worried some of you guys didn't know how to graph hyperbolas precisely, finding the asymptotes and the vertices and all that jazz. The vertices are important, but didn't I say you could cheat a little bit by plugging in -6 and 6? So if we plug in -6 and 6, trying to figure out what y is equal to, we could go ahead and solve just for a little bit and say, okay, well, -6 squared, I would plug in there. 6 squared is 36 with a negative. Add to the other side. We'd end up with a positive 36 and 9. Would that be 45? Add to this side, we have 45. So square root of 45 would be 3 root 5.
Yeah.
And to be honest, whether it's a positive or a negative being plugged in and squared, we get the exact same thing. 3 root 5 is approximately, anybody have an answer for me? Yeah, I'd say 6-2. It's 6 point something, something, something. So then we go ahead and we could say, okay, well, if this one goes up 3 down 3, couldn't we say, okay, let's go 4 and a 5 and a 6, and then go 4 and a 5 and a 6. So when x is positive 6, we can go ahead and say, hey, it's going to be a little bit above 6 here. Then we can rotate that in the sense of have that symmetry on the other side. Do the same thing down below, and instead it'd be y squared is plus or minus. So we technically have plus or minus, we have 1 up top, and we have some down bottom. What are we supposed to do with this hyperbola once we have them?
Revolve around the y-axis. So it'd be 2 sheet.
You guys agree with Sean? What do you think, 2 sheet or 1 sheet if we revolve around the y-axis?
It would be going like this.
Does that make
So
sense?
two
Yeah.
separate sections.
Good. Good visualization. So if you guys, the visualization will come naturally, and for others of you, it's going to take a little bit of practice. But yeah, when we spin, they are going to say, in a sense, self-contained, right?
Mhm.
We can make it snazzier, we can just say whatever, spin, 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 spin. 2 sheet, hyperboloid, done, done, done. Question real quick. Is this axis that we spun around the y-axis, is that the conjugate or the transverse? Just a quick reminder. Transverse, because it goes through the branches itself. Okay. So what else are you guys gonna see? Oh, what? Glorious, just kind of relaxed. You take notes, don't stress about assembly later on. Still about 14 minutes. Probably feels like forever. Sorry, hang in there. After this week. And zoom, zoom, zoom. What are we graphing this time? Come on. Oh, we got a graph line.
We sure do.
We have y equals mx plus who's b?
1. No, 0.
0 because he's not there. So where's my y intercept? How do we get to another point?
Just got more.
One
Use the
up.
substance, 3, rise up 3, and cross the right one since it's symmetrical. You can do
Yeah.
both.
If you ever slope 3 over 1, 3 over 1 means up 3 over 1. Up 3 over 1. Why am I doing 2 of them specifically?
Because then we are already within our limitations.
It says from x equals negative 2 to 2, so I just go ahead and go up 1 over 1. Sorry, up 3 over 1. That's when x equals 1. Up 3 over another 1, x equals 2. Okay, stop. Don't go any farther. And I have to go back the other way, so down 3, left 1. That's for negative 1. Down another 1, 2, 3, left 1. That'll be for negative 2. Within my restrictions, go ahead and stop as well. Now Sean said something about like in keeping, I think, with symmetry or something to that effect. So you can draw the other direction as well. What is he meaning? What are we going to do with this line?
The -2 to the axis.
Make negative 2. I'm not sure if that's how I put it. Where are we spinning him around?
Oh,
So you don't have to. So we're going about the y-axis. I guess I could put it down below. You can put it down below. We could go about the y-axis. And as we go about the y-axis, this is going to spin. And whenever something spins, doesn't it also go on the other side? Does that make sense? So it's only drawn one direction, but as I spin that, can anyone tell what this is going to make? Yep, a double make cone, just like the beginning of section 10.2, the pictures you guys didn't like that. But to make it a little bit easier on ourselves, can't we just say, well, if it's symmetric, then I'm going to have the point spin around to this point, right? If I get the point in there. It's going to spin there, but this one's also going to spin. I can do the other point because that's going to spin around to be 1, -3. 2, -6 is also going to spin around. So in a sense, we could go ahead and draw a line on the other side as well. I think that's what you were saying, right? Like you can do the lines on both sides.
Yeah. Through the lines.
So even though we talked about a paraboloid, an ellipsoid, and a hyperboloid, we can also make cones just by spinning lines. Interesting. So maybe what was daunting, remember you guys were like, do you have to draw that? Maybe it's not as bad as you thought now. Then we can. I guess the whole like slicing through thing is still kind of weird. This could be cool. Weird.
It's the better way.
Kind of cool. Getting some perspective. Okay, so that's all homework is, huh? Ooh. That's not bad, is it? 1, 4, 5, 7, 10, 11, 13. Wait a minute. But,
Wait, what's going on right now? Please.
question, kiddos, what homework problems do you have on your actual worksheet?
Go.
Someone, open your worksheet and tell me what we've done so far. What problem does it help us with?
1, 4, 5,
Yep,
7,
yep.
11, yes, oh.
Does 11 have like a something inside of something else?
Triangle.
We have stuff inside of stuff. We haven't done stuff inside of stuff, but the SAT has. Hold on, let's go talk about stuff inside of stuff.
Miss, when you go over these problems in class, or just when we use the odds, like on the left with the answers, so we actually.
We'll go over the evens. Okay. So I think there's like 1 or 2 evens.
Okay.
And then we'll go over questions on it. Okay. Struggle. To do the rest of the homework to do, okay, it's only 2 problems, but to do 11 and 13, we kind of have to talk about inscribed figures. But the really cool thing is you guys have already kind of done this when we did that worksheet. I can show you what it looks like. Although it's strangely waterlogged from someone putting, I don't even know what on it. Gone. Although it's not brown. Probably like at Christmas when I have snacks and I put like a steamy lid or something on it. Remember this one?
Oh yeah,
People at semester, I'm sorry, you would not remember this. But everybody else.
I do.
This was the one where we were graphing parabolas and completing the square and talking about vertices and axes of symmetries. Good thing we didn't have multi directrices or you would have like been more than you already were. We talked about how maximums or minimums are of the y values at the x values. And didn't we have these weird, what is the maximum height? What is the maximum height? Oh, both of them are heights. For the dimensions of the biggest yard, the largest area, fencing going around, making 2 paddocks. Paddocks? Did you say that? Horses? Paddocks. It is paddocks. Anyway, you should ask the Lord that. Okay. So this isn't really that new, except problems might just be a little more complicated because we have, or we're using not just parabolas, we're using other functions as well. And we have a shape within a shape. So you guys have seen inscribed figures before, right? Something inside of something. Something inside of something. And how do we inscribe a figure? Well, we make the figure go as big as it can, meaning it's going to have edges or corners on the actual shape it's inscribed within. It goes as far as it can and it has to stop. Like in the SAT we talked about the other day, the square inside of the circle, or the circle inside of the square. That was a while back. So there's 2-dimensional inscribed figures, and then there's 3-dimensional inscribed figures. Dun, dun, dun. The very first thing you want to do is get a picture. Now the really cool thing is, guys, on these inscribed figure problems, you can totally use your calculator. Oh, You can totally use your calculator. You guys see my calculator snapshot, right? How did I get that if y is not by itself? Make y by itself. So y is equal to, long story short, I subtracted the 64x squared, which added to the 1600. I divided by 25 and was too lazy to reduce because whatever, it's going in my calculator anyway. And I put a square root, only positive because, what did it tell me over here?
Y is greater than equal.
Yeah, so forget the plus or minus, I only had to do the positive one. Okay. Can you plug and chug something like that to your calculator? And the answer is yes. The crazy thing is if you plug in y is equal to 0, you actually notice, even though sometimes calculators stop, the picture should have kept going. Just the pixels kind of, we talked about this before. Sometimes the pixels, there's not enough room to go over and down without having some error and like going too far, so then the calculator just stops. So even though the calculator stops, we should connect it all the way down, because if you plug in y is equal to 0, you get x is equal to, I think it's 5 and negative 5. 1600 divided by 64 is, I think, 25. Okay. With this, how do we put a rectangle inside of him? Well, put some vertices on them and say, well, the rectangle's going to hit somewhere. And wherever the rectangle hits, that's going to connect in a straight line because it's a rectangle. And then it's going to go down because it's a rectangle, and it's going to go down because it's a rectangle. Now, guys, I drew one randomly. Could we also draw another rectangle randomly, since they haven't really told us what the dimensions are of said rectangle? I wonder if their areas are different. What do you guys think?
Yes.
The answer is yes. Area. Well, wait a minute. If there are like infinitely many different rectangles we could fit in, how on earth do we figure out the maximum area? Well, we use equations. Using equations, we say all of these vertices, I don't know exactly where the perfect one, the best one hits, but all of them hit at an x and a y. All of them hit at an x and a y. And if they hit at an x and at a y, then I can actually show the dimensions of a general rectangle within this parabola as having. Ready? I'm trying to figure out who's the base and who's the height. Because area of a rectangle is base times height. But I don't want b and h. I need x's and y's because my clue, this equation that ties it all together, needs x's and y's, not b's and h's. So, question. If x starts in the middle and goes out, how many x's do I need to make the entire base of my rectangle? One more time. If x starts in the middle and goes out, how many bases do I need to get the entire base of my rectangle? 2 x's. So base is 2x. So it starts in the middle, x starts in the middle and goes out, so I need 2 of those to make the base. And y starts from the x-axis and goes up, right? So if that's y, all I need is 1y. So I can be super snazzy and say, oh cool, so A, or area, is equal to base 2x times height, which is y. And then you're like, well, that's a great equation and all, but you have 3 variables. Graphing calculator's good, but it's not that good. It can't graph 3 variables. Maybe we should look in our handy-dandy notebook and say, we have another clue. We know who y is. It's okay, we're putting it in our calculator, so we don't mind. So then we're going to go ahead and we're going to take that a, we're going to plug in said y, 2x times the big old nasty whatever, calculator can handle it, square root of negative 64x squared plus 1600 all over 25. Whew. What do they want us to do to this function or of this function?
Solve for x as a function of a.
Find the maximum area of Now, is there a really cool, nifty feature on your calculator that does this for you? But in order to use this cool and nifty feature, what do you have to do to any equation that you're trying to find the maximum of? Profit. I put in this function to my calculator, I graphed it, and guess what I can see on the graph when I get the window all nice and perfect? The maximum. And what did I find? Using the cool said calculator feature. The maximum. And what can I answer at the end of the day? Well, A is 40 because Y equals A, and X is 3.535 dot dot dot.
Dun, dun.
And kiddos, in homework, this is like number 11. What's number 13? We have 15 seconds. Number 13 is just a challenge problem to see if you can do it just because I'm curious. There is a little step-by-step of what I did do. But the long story short, just see number 13 as a challenge problem. Just see number 13 as a challenge problem. What to do if it's three-dimensional. And we'll talk about question